All right, guys, so in this video, I'm going to show you how to graph exponential functions. Yippee yay, right? Here we go. So here's just an example that I've got for you. It says make a table in a graph for the function y is equal to 2 to the x power. Okay, so we're graphing. This is an exponential function here, and we need to graph it. So the step one is to make the table, right? We need to make the table here first. And so here's what I always recommend doing. We're going to make a table with x and y. However, I like to make sure that, especially when you're starting out with these, that you are also putting in the equation. I think it just helps you as you are solving for y, right? Now, my personal recommendation is you always start out with the number 0. Okay, so when you do that, you understand kind of where the the y-intercept is, because remember the y-intercept is always in the location when x is 0, right? And you may not remember that. You may remember it. Hopefully you do. If you don't, it's not a huge deal, so don't worry. But essentially what you've got here then is that you've got 2 to the 0 power. Now, 2 to the 0 power, if you don't know how to do that, grab a calculator, do 2 to the 0 power. But anything, this is the rule, so you really don't need to use a calculator. The rule is anytime that it's to the 0 power, the value is 1. So 2 to the 0 power is 1. That means that when x is 0, y is equal to 1, okay? Now, you'd have to figure out what kind of a scale to make for your graph. And so you want to get a good idea of what is happening with your function, because that's kind of the most important part. So I would kind of go in and start doing the next numbers. Maybe I might start with 2 over here. If you wanted to choose 1, that's okay, as long as you're able to see the shape of what the graph or what the function's really doing. So again, this would be 2 to the 2nd power now. And we know that 2 to the 2nd power is just 4, right? 2 times 2 is 4. Okay, so I see that it's increasing here quite a bit. So I'm going to maybe do a whole nother one, go up another 2 more, and make this y is equal to 2 to the 4th power. And we know that 2 times 2 is 4 times 2 is 8 times 2 is 16. So 2 to the 4th power is actually 16. So we see that this graph is really, it's starting to take off here. And so I can probably just halt right there. That's probably enough numbers going that way. But I also need to see what's happening the other way, right? So maybe what's happening at -2. Y is equal to 2 to the -2nd power. And if you don't know how to do this, you'll want to put it into your calculator. Desmos is an absolutely great tool to use. In fact, I'll pull up Desmos right now to show you guys how to do that. We said it was 2 to the -2nd power. So if I just put in here 2 to the -2nd power, I believe I can use this one in Desmos. I end up getting 0.25, or as a fraction, that's 1/4, right? So I'm going to throw this back up here real quick. That means this is going to be 1/4. So we can see that it's just getting tinier and tinier and tinier. And if I do the exact same thing here and maybe make it 2 to the -4th, pull Desmos back down. Hello again. Make it bigger. If I just change this to a 4 now instead of -2, -4, I see it's just getting very, very small to 1/16, right? Now, you might see that that is enough information for you to kind of make a good graph. If not, then you need to find more coordinate points, and that's totally okay. But I feel confident enough that I can make a graph that kind of shows what this is doing. And I'm noticing here that my x values are ranging from -4 all the way to 4. So when I build my x coordinate, I need to make sure that I have from -4 to 4. In fact, I can go over here and I can I'll put 0 in right here. And I think I'll space them out. We'll go over like this, 2 and 4. And then I'll go backwards and do -2 and -4. Remember just that when you're graphing these, the scale needs to be consistent. So just as a quick example, I'm not going to put this as 16 here because that's not consistent, right? That should be 5. You need to make sure that they're a consistent number. Oh, didn't want to do that. Okay. All right, so then we need to find our y-axis. And we see that for y, it never gets below 1/16, which is a really, really small number. So really it's starting as small as I get is 0. And as large as I got was 16. So I might take this up to 20 just to kind of make sure that I show that. Really not gonna say that it's not good if you get lower than 20. And I might also just put a -1 in there just to kind of show that part as well. I'm going to shift over to green here just so that we can see it a little easier. And we'll go right up to here. And if I wanted to go up to 20, I want to make sure that my scale is going to fit. For example, if I go by 2s, that's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. It looks like I can go by 2s, but if I did by 1s, that would be way, 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 way too big, right? My graph would end up going way too far up. So if I go by 2s here, that's okay. I'm just going to put my scale on here. There's not necessarily a wrong way to do this as long as you're showing what the graph looks like, right? You want to make sure that you can see what's happening in as you're plotting these points and when you're graphing it, okay? So now I'm going to build the line, right? And I see that when x was -4, y was 1/16. I'm looking right over here at my table here. When x was -4, y was 1/16. So I'm going to go over here and x is -4, y is -1 or positive 1/16. That's like right here because 1/16 is really close to 0, right? Then my next number, when x was -2, y was 1/4. So we're still really, really small because think about that. 1/4 is 0.25. It's really just kind of sticking right around here. My next value is 0, 1, right? So I'm going to go back over here, grab the right dot, sorry. So when x is 0, y is 1. And then I'm going to keep on going. When x was 2, y was 4. And when x was 4, y was 16, all the way up here. And see how my graph, you can really start to see how the graph is taking off. And so now I can start to draw this in very, very carefully to show the curve of the graph. And so we can see by this graph that it is increasing as x is increasing, right? As x is increasing this way, the graph is also increasing this way. And so that's how you're going to make a table and a graph, and how you're going to graph an exponential function is just kind of by following that same rule. Sometimes you might end up having a list of 10 numbers or something that you've tried out for x, and they might be out of order or something like that too. You have to just kind of test things out and see what numbers you should use. I'd always start with 0 though, and then I'd kind of go from there. I hope this helps, and if you have any questions, obviously let me know. Thanks, guys.